Looks like we should be live. All right. Long time no see. It's been a while. We could say that we were on a break, although most of it was just, you know, being busy with other things, and it was 70% being busy with other things, 30% just kind of being lazy. And also, no, okay, 20% being lazy and 10% not being happy with the audio quality of my setup. In fact, today's stream is kind of meant to be a test stream to see how the audio comes out. So depending on how that goes, I may or may not stream tomorrow. Not that that'll be entirely up to the audio, but the quality of the audio for this stream is gonna affect the decision to come back tomorrow. So, yeah. But my hope is to, starting this week, get back into the rhythm of streaming again. And I do realize that the last time we did a stream, I have not even looked at the last one or two videos that or streams that we did, just to, I guess, recollect. I have not even done that, so I don't perfectly recall where we left things off. But I think I was in the middle of reading the Rust SQLite rewrite, Limbo. I think I was in the middle of reading that, and I think the idea there was that we can try to not re-implement, but try to, I don't know if re-implement is the right word, but basically use the lingua franca programming language to, I'm struggling to find another word, but I guess for now we'll just say re-implement, but it's not really a rewrite. It's more like using lingua franca as a coordination framework around the simulator. That's not completely dead. At least I don't think so. I'll get around to it. To be fair, well, there are other things that are kind of on my mind that I want to do, that feel like they'll be more interesting than doing that specifically. So I might not get back to it right away. But it shall happen at some point. When, I don't know. I think I've learned a lesson in my very non-existent short career as a streamer, that you have to be very careful on the things that you say you will do, especially when it's things that are not just like one-off sessions. Like, you can't just, like, I just don't have the luxury of like doing a 4, 5, 6 hour stream, in one sitting. So, at best I can do 2 or 3 hours, and that'll be in the evenings on weekdays as well. So, it's hard to make these like lofty plans on, we're gonna rewrite this whole thing, and because then that's like, give or take, that's at least 5 days, if not more, of consistently sitting and doing the same thing um, for 5, 6, 7 sessions, and that's assuming that nothing else uh, comes up, and whether it's your 9 to 5 job or just life. And if something does come up, then it kind of just takes you out of the groove, so to speak. Anyway, so yeah, I think I've learned my lesson on making plans for what kind of stuff I'm gonna do. I think going forward, I'm just gonna see what clicks, what feels right in the moment, and just do that. And if that means that there's not a perfectly coherent series of videos, one after the other, in succession or whatever, then so be it. I mean, it's not like anybody's watching for the most part, except the people who've actually watched any of my videos. Thank you. I hope that they were of any use at all. But yeah, I don't feel like I'm really beholden to anybody who's like expecting anything. So I feel like I can just kind of do whatever. So less pressure to do exactly one thing, because I said that I will do it in terms of planning. Yeah. Anyway, ramblings done. I think. Today we're just gonna go through this article from Jack Vanlightly. I hope I'm pronouncing that well. He's one of the so I follow him on Twitter, and I believe he's one of the main people who works on the Kafka distributed systems. At least I know that he does a lot of I think the first time that I became aware of his work was through GitHub. I know he has a lot of TLA plus. Where was I? Yeah. A lot of GitHub TLA plus would that be called implementations or modeling? Anyway, I've followed his blog for some time now. He does really good writing. So if you are interested in distributed systems in general, definitely a solid blog to follow. He has really good TLA plus specs that you can read as just learning material, to get familiar with TLA plus. So yeah, we're just gonna go through this, and I guess going against my own advice my own rambling that I just went on about how I shouldn't make this forward thinking plans of all the things I'm gonna do, but I think it's okay. I don't feel too much pressure in terms of saying that we'll go through. He's going through a series called Coordinated Progress. I don't know if part 4 was the last one. Yeah, in this last post. So it sounds like that was the whole series, 4 of them. I think we'll just as we get back into this into the rhythm of streaming, I think we'll just go through those 4 articles one by one, starting today. If I manage to get started soon, because it's getting late. I don't want to start and then not finish. It's not too long. I think we can manage. All right. So that's the plan. We'll do part 1, and again, I guess I'm a sucker for punishment or whatever. The plan is to read all 4 parts this week. We'll see how that goes, but it shouldn't be too hard to do so. Yeah. All right. Let's just do it. Coordinated progress, part 1, seeing the system, the graph. At some point, we've all sat in an architecture meeting where someone asks, should this be an event, an RPC, a queue? Or how do we tie this process together across our microservices? Should it be event-driven, maybe a workflow orchestration, queue with flurry opinions, whiteboard arrows, and vague references to sagas? I feel like there was a period of time where the word sagas was on every fucking blog article. I feel like it was around the time when tempo really starting to pick up. I think if I remember right, and my memory may be, it's definitely imperfect, but I feel like temporal was the beginning of people really starting to talk about workflows and durable executions. Durable execution and workflows, especially within the context of just application microservices or API microservices. I feel like there was a time when temporal just was dominating the microservice. Well, okay, maybe dominate is a stretch, but it was very picking up momentum, and I feel like the word sagas just kind of became a thing that people would just throw around. At least that's my impression. I could be misremembering or whatever. Anyway, now that I work for streaming data infra, now that I work for a streaming data infra vendor, I get asked, how do event-driven architecture, stream processing orchestration, and a new durable execution category relate to one another? Yeah, lots of words. Anyway, these are deceptively broad questions, touching everything from architectural principles to practical trade-offs. To be honest, I had an instinctual understanding of how they fit together, but never written down. Coordinated progress is a 4-part series describing how I see it. My mental framework. That's what it's all about. Having a good mental framework for a lot of these concepts. You don't necessarily have to have all the details down, but at least having some mental framework of how the pieces are supposed to fall together helps a lot. And once you find yourself solving actual implementation details, whether it's at a low module level or when thinking about the interaction between multiple services, having that mental framework in the background really helps to have a framework. of reference for making decisions. Um, anyway, and hopefully it will be useful and understandable to you. And yeah, also I want to say it's really we should really appreciate the fact that people like him actually take the time to write this stuff down. Yeah. I anchor the mental framework in the context of workflow, using the term in a broad sense to mean any distributed work that spans multiple services, such as a checkout flow, a booking process, or an application pipeline. Many people use the term saga to describe long-running workflows that span multiple services and require coordination and conversation. This analysis uses the more general term workflow to capture a broader class of distributed work. Yeah, the word saga, man. I'm telling you, there was a time when people would just throw this word around, and you're like, okay, we're still talking about workflows, right? At least in my head, like, yeah. Anyway, series TLDR. So obviously this is the first part, so there was a lot of introducing the whole, the whole saga, the whole saga of articles that he's about to drop on us, all that knowledge he's about to drop. Anyway, so modern systems are no longer built as monoliths. You know about this. I don't know. I feel like there are lots of systems out there who will probably do better being built as monoliths, especially when you realize that like a single Postgres instance, instance/server. Like I think OpenAI still uses a single instance Postgres. Now, one thing that I'm not so completely sure on is whether it's one Postgres instance/server or actually one single database as well, right? Because those are not the same thing. They give a talk. And by the way, I remember when I saw this talk, the notification for this talk on YouTube, one of the comments that I made in jest was, I think I how do you say the word no, I pinged, I guess. Is this Sam Lambert? Sam Lambert from, Planet Scale. And I was basically telling him, just watch. Within 1 or 2 years, OpenAI is gonna shift to Planet Scale on MySQL, because it just seems like, at least based on what the folks at Planet Scale are doing, and I don't think it's just Planet Scale. I think there are so many like truly like big distributed systems out there that maybe they start out using Postgres, but then they basically migrate to MySQL, or they started with MySQL and they just never looked back. But basically, it's more likely for a big company like OpenAI to transition from Postgres to MySQL than to go from MySQL to Postgres. Like, for example, I'm pretty sure Meta is a MySQL shop. Like, And I don't think that, like, I just don't imagine them being like, you know what, we'll switch to Postgres, right? Um, but I can totally see OpenAI within the next 2 years or 3 years being like, well, we tried the Postgres thing and now we're just gonna switch to MySQL. And yeah, and anyway, I made a joke to Sam saying basically, well, it's two part. The first one was basically, yeah, just watch. Within the next 2 or 3 years, they'll come knocking, uh, and just be ready to write a bunch of zeros on the check, basically. Um, and I think the second part, I think several days later. Oh no, it's recent actually when PlanetScale announced that they have Postgres support now. Um, I did another mention to Sam saying, okay, and it's official. Basically, you guys are gonna get acquired within the next 2 or 3 years. Um, I remember having the same ish feeling about Rockset, and Rockset did get acquired because Rockset was basically index all the things um, at scale, and for a company like OpenAI, looking at what they were doing, or I mean what they are doing, a system like Rockset just makes total sense. And so, yeah, Rockset did get acquired by OpenAI, and so I have that sneaky suspicion that that's what's going to happen with PlanetScale. Like, if I have to give a percentage, I would say within the next 2 or 3 years, I'm 80% sure. Okay, maybe I don't know. Is 80 too high? I'm 75% sure that OpenAI will acquire PlanetScale if somebody else doesn't. In the meantime, right? It may be that uh, uh, Anthropic decides to acquire them beforehand just because, but I don't see why. Like, yeah, I think yeah, I don't see it. Yeah, I just see. I think OpenAI is gonna acquire PlanetScale within the next 2 or 3 years. Anyway, so going back to the article, yeah. So the idea that I think there seems to be this obsession that we need, everything needs to be distributed by default, and I feel like, and I don't think it's just me. There are many people who can probably relate to this, and again, relating to that, finding out that OpenAI is actually running, like they're not running a distributed Postgres setup. It's like it's one server, one database, and through there runs everything. And how many products out there have the scale of OpenAI? So, or even Notion until recently, and for a long time they just ran everything on a single Postgres instance, right? And they didn't deal with the whole distributed thing. I think they eventually had to, um, and they even designed their own distributed Notion. I mean, distributed Postgres thing. They wrote a whole article about it. Notion distributed Postgres. Was it 2001? Oh no. Gosh, okay. Um, that's funny. I was not even what this is a mistake actually. Yes, I know Notion was using Postgres, but they're not even the ones that I was going to refer to. It was Figma. It's Figma. Sorry, it's Figma who uh, did recently build their own distributed Postgres thing. But for the longest time, they ran on a single Postgres instance. Anyway, all of that to say that there are lots of systems out there that just assume distribution by default. Like they want everything, they want to be distributed from the jump. When, if architected right, there should, like, a single node can do the job. And that basically removes a lot of just headaches, right? Because now you really have to justify using something like Kubernetes. Although, even like with Kubernetes, because with Kubernetes you can use something like K3s to even have still a distributed system that actually runs on a single node, right? So you start out single node, single container, and if you think that that's not good enough, maybe try something like K3s where you have, you can actually orchestrate multiple containers on the same node and see how that goes, and then, take it from there. Anyway, okay. Modern systems are no longer built as monoliths. There are sprawling graphs of computation stitched together by APIs, queues, and streams, implemented across microservices, functions, stream processors, and AI agents. Oh man. So many things. Anyway, complex workflows cross service boundaries, requiring coordination that must be both reliable and understandable, as well as flexible and adaptable. Within these graphs, the concepts of coordination and reliable progress are critically important. Coordination strategies shape how workflows are built and maintained. Choreography, reactive event-driven, provides high decoupling and flexibility at a cost. Orchestration, centralized, procedural, offers greater clarity and observability. I will agree as well. Like, somebody wakes you up in the middle of the night and says choose choreography or orchestration, 80% of the time you should probably go with orchestration. We'll just leave it at that. But not all edges in a graph are equal. Some edges are direct, defining the critical path of a workflow where failures mean failure. Others are indirect, triggering auxiliary actions in adjacent or even faraway services. A good mental model distinguishes between the two. Orchestration should focus on direct edges, while choreography handles both naturally. Reliable progress hinges on two core concepts. Durable triggers. Work must be initiated in a way that survives failure. Kafka queues, reliable RPC. Progressible work. Once started, work must be able to make progress under adverse conditions via replayability, using patterns such as idempotency, atomicity, or the ability to resume some saved state. Yeah, and I think the folks at Resonate HQ are really honing it. Well, they're really focusing on that part, I think. Wait, is it not Resonate HQ? Workflows are distributed async. Resonate. Yeah. The CEO is Dominic Torno. I hope I'm pronouncing that right. Distributed async. They've actually laid out a whole protocol for how to do distributed and durable promises. It's pretty neat. Distributed async await. Yeah. Yeah. Anyway, while stream processors, Flink, Kafka streams, and event-driven systems. Oh, gosh. I like and also despise this part of my brain. Speaking of Kafka, I think LinkedIn recently came up with something that they're seeing as a Kafka replacement. Job description. Must have 10 years experience. Enough, God. Okay, so it's not open source yet. I started reading the article. I didn't finish it. Maybe I'll read it on stream at some point, actually. Where is it? I want the original. I wonder, is it written in Rust? Oh no. Yeah, okay, this is the article. Let's do a Rust. Fine. Okay, no, there's no Rust. Alright. I think LinkedIn is mostly, well, okay, I need to be careful. I was going to say mostly a Java shop based on the assumption that, they've built Kafka. So, I mean, and they also, I think Apache Pinot is also out of LinkedIn, if I remember right, which is also Java. Yeah, I feel like, could be wrong, but I feel like LinkedIn is a Java shop when it comes to the distributed system stuff. Anyway, so yeah, LinkedIn is apparently going to move beyond Kafka with this thing, Novgod. Does that mean I wonder what that means for the industry? Because I mean, they are the OGs of Kafka. So if they think they've outgrown Kafka, then what does that mean for the rest? I mean, for 90% of people who are using Kafka today, they should just stick to Kafka and not even pretend like this does not exist. But I mean, if you're a place like Uber, you probably want to start. I mean, I would imagine there are people out there at Uber who are aware of this now, or they've been aware of it, and they're like, is there something we should also be looking into? Anyway, all right, let's come back. Let's stay focused. Okay, while stream processors, Flink Kafka streams and event-driven system based on queues and topics have durability built in, imperative code typically does not. Durable execution engines Yeah, temporal. Yeah, I think it's fair to say that temporal. It is from, yeah. I want to say that it's like the OG. Like it's, I feel like it's the one that really like started to inject the idea of durable workflows and all that into the quote unquote mainstream. Uh, yeah, and then WeState, I'm aware of WeState. I think the whole stack is within Rust even. I think they had a recent rewrite of the original orchestration server, and now it's like a single binary, very convenient to start working with. I don't know if they're still. I think they had first class um, integration with AWS Lambda. I don't know if they've expanded beyond that, and now they're just like a regular. Yeah, I don't know. Like I don't want to click on it to go find out because I don't want to get on another side quest or whatever or distracted. DBOS, been aware of them for a very long time. In fact, I'm pretty sure that I'm the first one who forked their repo when they first officially came out as a company. Before that, I think a year and a half, maybe, or maybe even 2 years before that, I saw a talk by Stone Baker. He's one of the OGs of Postgres, where he was making the case for rewriting the operating system as a database. I think the ideas there, which are far more I guess aggressive, you can say the word, than whatever the current product of the. I feel like the current product is just a matter of, it's the product of. It's just a product for web services. But my understanding is that the fundamental, really like deep idea that Stonebaker has is around literally just rewriting the operating system as a database. And I remember seeing that talk and thinking, wow, that's a big idea. And started paying attention, and I think he had one or two PhD students that were working under him, and they came. They had a bunch of research papers. One of them was the precursor of what is DBOS today. It was written in Java, if I remember right. Yeah, and even back then I remember seeing and thinking, this could be really neat. And then there was another paper that came out, and I think that one is called Epoxy. Multi-store transactions. Yeah, Epoxy, yeah. Peter Kraft and Quenley. I think Peter Baylis. I don't know if all four of them are still at DBOS, but I'm pretty sure that Peter Kraft and Quenley are the two leading DBOS. At least on the, engineering side of things. Well, on the IC, individual contributor side of things, Stonebaker is the CTO, or maybe it's no, not the CEO. I think the CEO is somebody who used to work at Reddit. If I remember right, he used to be somebody at Reddit. Or maybe I'm confounding him with somebody else. Anyway, Peter Kraft, Quenley, yeah. this research paper. I think I read some. Yeah, the original version of DBOS was called Apiary. That's right. But yeah, there was this research paper where basically you can do transactions across multiple stores, which was really interesting. Obviously, the complication there is that it's almost like the same issue you run into with infrastructure as code, where in a perfect world it just works, but then there's always that idea of a drift, where yes, you can think of, let's say you have a Postgres, MongoDB, and MySQL triad of data stores that you are logically using as a transactional, a federated transactional system. And that's fine, that's great. But the problem is, does that model, or does every client and tool that interacts with each of these databases have the same context or understanding that these three stores are supposed to logically be transactionally consistent between all three of them? And so you start talking about the idea of, state drift, where, maybe a client is interacting with just the MySQL database in this case and making changes that ultimately are conflicting with the federated state or logical state of the triad of, the epoxy protocol. So that's the challenging part, but the idea itself is actually pretty neat. So if you can figure out a way to handle the drift problem, this is a pretty good setup for some use cases, at least. Resonet, I think we just talked about it. Little Horse, I heard it. I think I was reading a blog from gosh, I forget his name. He's one of the co-founders, if not the founder of what's that this storage engine that's supposed to be diskless with the S3 as the backing stall. Shit, it's one of the recent ones. Memory game. Do I remember? Shoot. I even reviewed some PRs for it. Gosh. Playing a memory game. Gosh, I can't remember it. Shoot. Anyway, was one of the co-founders of that, and I read his blog post. That's when I became aware of Little Horse. It's another, durable execution thing. Not as familiar with this one, admittedly. And I'm guessing it looks like it's a Java thing. Yeah. Anyway. All right. Gosh, at this rate, we're gonna end tomorrow. We're gonna end reading this tomorrow. All right. Let's see. Where are we? Okay, and Little Horse, among many others. Aim to fill the gap in a world of imperative functions that provide varying tooling and language support for adding durable triggers and progressible work to imperative procedural code. Oh, by the way, sorry, my mind doing the thing again. I think there is a Rust package or framework that also handles durable execution, but it's not listed here. Oh, shoot. Is it flawless? Memory game. Am I right? Yes, that's it. Flawless. Flawless.dev. It's another one. Execution engine for durable computation. There's another one actually. another one. There's another one. That one I don't think I remember the name. It has yeah, the name is not really catchy. Honest. I didn't think so at the time, which is why I can't really remember it right now. What was it? Anyway, but that one, it's kind of similar to this one as well. Well, it's similar to a lot of the stuff that we listed. They're all kind of, well, they're all similar to each other in some way. Anyway, the last one that I am talking about is it uses WebAssembly as a way to really handle non-determinism. And besides that, there's another one that just came to mind. Golem. Is it Golem or Golem? Golem Workflow. Yeah, there's this one too. Golem. I'm pretty sure this is built on Rust. The server is yeah. Oh wait, did they change the license? Ooh. Oof. All right. Oh, maybe. Okay, wait. Let me make sure before I start making assumptions here. Is there a Golem server? Oh. No, I think they switched the license. I mean, that's what it looks like. Because I could have sworn this was open sourced as Apache. Let me see. Nope, I did not fork it before. Yeah. Well, my fork is from last year. And it's this behind. And yes, the license was Apache 2.0. So somewhere along the line, they decided to switch from Apache. I wonder why. Wait, change license. Yeah, I mean, I don't know. Maybe you read the fine points and it's not such a big change, but oh, okay, this license is not an open source license. Well, it used to not be like that, as I just displayed or showed. When I forked it, it was Apache 2, but there are 2,000 commits, so I guess my fork is a year behind. They've added 1,000 plus commits since then. Anyway, so that's another one. Another orchestration framework for durable executions. execution or executions? I feel like the tone makes a difference. All right. All right. Let's move this along. This analysis constructs a conceptual framework for understanding both coordination and reliable progress in modern distributed architectures composed of microservices, functions, stream processing, AI agents, and cranial building blocks made available by DEE, durable execution engines. Okay, frameworks. It's graph all the way down. It is. And that's because it's all state machines all the way down. So you end up with graphs. The graph. Do you want to know what it is? Yes. The graph is everywhere. It's all around us. Even now, in this very server room, you can see it when you look at your IDE or when you design your Flink topology. You can feel it when you work on microservices, when you handle incidents, when you deploy. That's pretty good. I like it. That was pretty good. It's graphs all the way down. Yeah, but I guess more fundamentally, it's state machines all the time. At every level of abstraction, computation reveals itself as a graph. Something that also just came to mind. Gosh, I'm not gonna finish this article, am I? Speaking of state machines, I feel like I have this old man like rant almost every other day with the whole agentic system, agenting that, and anyway, I guess to keep it short, the idea for me, I mean, my thinking is that it's all state machines. Database systems are database and storage systems are the way that we ultimately handle large distributed state machines at scale. Another thing is it's almost always a mistake to move data to compute. Compute should almost always bow down and move to data. And I think LLMs, machine learning agents, whatever you want to call them, this AI thing, is just a compute primitive, and ultimately it will be moved to the data. And I like to joke to my coworkers sometimes and saying this whole agent thing, the industry is gonna fuck around and we discover that really all we really need an agent really is just a query engine and a scheduler. Well, it's really a query engine, and it's also kind of a scheduler. Technically, I think a query engine is also a scheduler. I don't know if I have the right combination of words to properly prove that. But yeah, I think AI agents are really meant to be. It's a compute primitive, and I think ultimately they're just gonna be, for them to truly be useful at scale and not be a drag as systems scale to be larger and larger and larger. They will have to be moved as close to the data storage as possible. And to me, that means really being infused into the query engine. And yeah, I guess I guess I'm a little I don't know. I guess maybe I don't really have a point to make here, except that I this whole agentic this, agentic that, and all that. It's just yeah. I feel like I don't get it. Like I don't get um the obsession, so to speak. Where it seems like yeah. I think I'll be very once we get to the part where the so-called agent, are directly part of the database. I think we'll have it will make things very very interesting, right? Like imagine that the DuckDB query engine is AI native, whatever the fuck that means, right? Whatever the fuck that will mean. It's like you have your DuckDB, and as part of instantiating the client to talk to a DuckDB database, you set up a configuration option that says, "Hey, connect me to these AI models or tools or whatever," and that's just like part of the fabric of the query engine itself. Like that will make for some very interesting things. Um, like how much of ETL work will be um, will be solved if you add such a thing. Of course, then the assumption here is that for it to be part of a query engine, something like DuckDB, where you can just like you're expecting results to be more or less deterministic, or the behavior is like there's a set of expectations, when you're talking about the query engine of a database. And so the models will have to be very good to be able to be fused or included in these like high profile, super well engineered query engines. But I think that's gonna have to be the case for AI to really make sense and start really being useful at scale. And really, like, I'm not talking about demos and all that. I'm talking like really processing a serious amount of data and providing very useful insights on data at scale. I think you really need to move the primitive near the data. Whether it's in the transactional databases or the lakehouse. I think once we get to that point, then it will start to be really impressive, at least to me. And then you start having it be, again, sticking with the theme of moving the compute to the storage. You start talking about having it be part of the protocols for the storage engines, like being able to predict node failures in a topology of in a RAF topology, being able to anticipate or detect failures, and being able to automatically I guess, autonomously remedy the faults, uh, and do so without, any human intervention. And then also talk. That's one aspect with the protocols. Another aspect will be, in terms of, learn indexes, understanding the usage patterns. Yeah, and just, doing some auto tuning. In fact, I think, what's his name? Gosh, the guy from CMU. I forget his name. Andy Pavlov. He has a really good series on databases. I think he worked on a startup, a company for auto tuning databases, and by his own, his thing is that it's actually super hard to do auto tuning. And so, if we ever get to the point where the AI is so good that that's no longer true, that'll be very interesting, right? To have your agent be part of your query engine, part of your maybe even the storage format, or at least figuring out in real time what's the best way to lay out, to do the data layout, things like that. Like, there are so many things that AI can really be useful for with data, that once it's able to do that, to me, that will be like really like, okay, we've really crossed a threshold here where these things are really truly useful and very impressive. Anyway, that was a side quest. Now let's get back to this. And oh boy, am I gonna get through all this? I will if I stop going on tangents. Alright, at every level of abstraction, computation reveals itself as a graph. A function in a microservice contains a control flow graph comprising branches, loops, and conditionals that describes its execution logic. A Flink job is explicitly a directed graph for operators and stateful nodes connected by streams. A workflow that ties together multiple services, whether via orchestration or choreography, is also a graph, and that represents dependencies, event flows, or command sequences. Coordination plays a critical role in this graph or graphs, and is also present at every layer. Within a single Flink job, it is Flink itself that coordinates work across multiple task managers. Within a microservice, the executable code acts as a linear or concurrent coordination of multiple steps that may invoke other services or data systems. However, it is the coordination required for workflow across multiple systems that represents the largest challenge. Distributed coordination across heterogeneous systems, programming models, and environments is a strategic concern for organizations with far-reaching consequences. This graph, made up of workflows spanning multiple systems, can make discussing topics of programming models and coordination methods confusing. For example, one consumer in an event-driven architecture may execute its code procedurally in an imperative style, but play the role of a node in a reactive system architecture. A workflow can be triggered by an event which acts as a reliable trigger for retries, or it might be triggered by an ephemeral RPC. The types of nodes and edges of the graph matter. Node, edges, and subgraphs. Well, everything is a graph, even code. For this analysis, let's confine things so that nodes are microservice functions. FAS, function as service, functions, stream processing jobs, and AI agents. Okay. Edges are RPC, queues, event streams. These vary widely in semantics. Some are ephemeral, others durable, which affects reliability. Workflows are subgraphs. Or connected components, as in graph theory, or excuse me, what the fuck? Subgraphs are connected components, as in graph theory of the graph. Sorry. Or subgraphs of the graph. Okay. Nice little picture here. Alright, let's move on. Direct and indirect edges. What constitutes a workflow is debatable, especially with the broad meaning I'm using in this analysis, but I like to think of workflow by the types of edges, which can be direct or indirect. Edges also have other properties such as request response versus one way, and synchronous or asynchronous. But for now, we'll keep the model simple and think about whether edges are direct or indirect. Direct edges trigger work that is central to the goal being performed. Using an example of an order placed workflow, there might be a set of microservices to handle the payment, reservation of stock, initialization of shipment, preparation, initiation of shipment preparation, which are all directly tied to the order. These are all connected by direct edges and form the core order placed workflow. And direct edges trigger tangential auxiliary work, such as notifying the CRM, the customer management. No. Come on. Focus. Such as notifying the CRM for customer management, a finance reporting system, or auditing service for compliance in your order workflow. An indirect edge could even trigger a secondary core workflow, such as just-in-time inventory process. Whether an edge is direct or indirect will influence what kind of communication medium is chosen. Coordination. I'm just trying to actually read through the thing without too much interruptions because we're running out of time. I got a job to go to tomorrow morning. Okay. Let's see. Coordination. Workflows require coordination. Okay. Whether that coordination is just a dance between independent services or something more centralized or controlled. There are two main coordination strategies, choreography or orchestration. Choreography, event-driven workflow, and it's reactive. Highly decoupled microservices that independently react to the input events as they arrive. There's no blocking or waiting, and all consumers operate independently of any upstream producers or subsequent downstream consumers. I mean, this sounds great in theory, but it can really get out of hand fast. Orchestration, procedural workflow, if this then that. Logic is centralized in some kind of orchestrator, even a microservice or function, issuing commands and awaiting responses from subordinate worker microservices. The orchestrator keeps track of which parts of the workflow have been completed, which are in progress, and which have yet to be started. It keeps track of the commands sent to the subordinate services as well as the responses from those services. We'll cover choreography and orchestration in more detail in part 2. The role of stream processing in a graph. Stream processing frameworks like Apache Flink and Kafka Streams can be thought of as microservices with a configurable blend of continuous data flow programming model and reactive event handling, designed to transform and react to streams of events in real time. Like microservices, stream processors form logical graphs of computation using branching, joining, and aggregation to process data. However, their programming model is more constrained, being optimized for data-centric transformations of event streams rather than complex control workflow or handling individual requests on demand. In the context of workflows and sagas, stream processors fit naturally into event-driven choreography as nodes in the event graph not only perform transformations or enrichments, but also taking on roles that overlap with those traditionally handled by microservices, including stateful business logic and triggering downstream effects. Just as modern microservices are decomposed into bounded contexts, following domain-driven design principles, so to should stream processes be scoped narrowly. Embedding an entire business workflow into a single Flink or Kafka Streams job is generally discouraged. Yeah, makes sense. Instead, stream processors work best as individual nodes in a choreographed system, each independently reacting to events. Beyond participating as choreographed actors, stream processors play two valuable roles in Saga and workflow architectures. Real-time triggers for workflows, detecting an event pattern, user added to code but didn't check out in 1 hour. And emitting signals to start or branch. Workflows. Aggregated state for decisions. Continuously computing derived state that orchestrators or services can query or get workflow logic. In summary, stream processing can replace traditional microservices in choreographed workflows and enhance orchestrated workflows with real-time insights, trigger, and data transformations. However, one stream processing job will rarely include an entire workflow, such as a microservice would not. Just as a microservice is it's getting late, so bear with me. Just as a microservice will not. Okay, I can read and finish sentences. Great. All right, durability as a first-class concern. About this, I feel like I keep waiting for somebody to come up with a runtime and a programming language that makes this a first-class citizen. Or, just have it. I don't know, maybe that's too much to ask. In theory, you can maybe retrofit existing runtimes to make this a first-class citizen. I don't know, maybe that would just necessitate some breaking changes. But it would be nice to have this built into the runtime of the programming language. food for thought. Durability as a first-class concern. In distributed systems, durability is not just about data, but about progress. Indeed. A workflow that performs critical operations must either complete or fail in a controlled, recoverable way. Excuse me. Durable coordination ensures that steps don't vanish into the void after a crash or network fault. But more importantly, after the crash, the process of deciding whether a step should rerun is also obviously very important, or whether like being able to capture the fault that occurred, but also at which point in the step did it occur, to then make decisions about the rest of the workflow. That's like super not trivial, basically. No matter the execution model, procedural, event-driven, or data flow, durability is the mechanism that transforms ephemeral logic into reliable systems. Choreography in the form of event-driven architectures offers durability by default. Events are stored durably in a queue or log, enabling reactive systems to recover from crashes, replay history, and trigger retries. Each service reacts independently, and progress is tracked implicitly in the event stream. In this model, the event log acts as both coordination medium and source of truth, encoding the causal structure of the system's behavior. Yeah, okay. Like, for example, if this, excuse me, if you start from here, you pick this branch, in theory, this message doesn't go out if this crashes, which means that when this comes back up, it just needs to, because chances are, actually, that's not a guarantee, but chances are it did not acknowledge back to this node that it received this message. And so when it comes back up, it's able to just pull the same order again, process it, and then send the message, this refund failed message. But then you can get into very edge cases of what happens before what, whether it, and I mean, this is where you really have to pay attention to the way you're crafting these protocols for how nodes communicate with each other and acknowledge receipt of messages when they do so, and what that implies about moving things in lockstep, or the state of the overall system. Anyway, okay, when a crash occurs mid-execution, everything in the call stack is lost unless explicitly saved. Yep. This guy gave rise to the durable execution product category, which brings event log-like durability to imperative workflows. And so the basic idea is that you basically, before starting processing, there needs to be a mechanism for you to log the fact that you're about to perform a series of steps based on some input data that you received. Yeah, I think that's basically it. Like, it's like transactions in a database, right? You have the log, the wall, where you log the command before you actually ever apply it on the affected tables. Yeah, durable execution engines. Yeah, tempo, like I said, it gets usually mentioned first because, again, I think it's the service or product that really like was the OG of all these services, these durable execution engines. Okay, durable execution persist the workflow's progress, key variable, intermediate results, responses from other services, and so on, allowing it to be retried, resuming exactly where it left off. Yeah. I guess you have to summarize it. It's really just the persistence um, of computation state. I don't know. Is that a good way to put it? Yeah, I think like in very simple terms. It's really in the name, right? Durable execution. Yeah. Yeah, I really do wonder what, imagine if we had a time machine and we could build durable execution primitives right into, let's say, the Golang runtime. I'm not sure what that really looks like, but assuming that it's done well and it's engineered well, like how much code would you be able to delete today if that were the case? Yeah. Something to think about. Like if your runtime itself has primitives for durable execution. Anyway, durable execution engines, in effect, the Kafka imperative coordination, the Kafka of imperative coordination, aka coordination via orchestration. Durability is also fundamental in stream processing. Frameworks like Apache Kafka and Kafka Streams include native durability through state persistence. Yep, state persistence. Mechanisms such as checkpointing, chain logs, recovery logs, goes on. Ensuring that event transformations and stateful aggregations survive failures. While the diagram, while the paradigm, while the paradigm is data centric and continuous, the core concept is the same. Progress is recorded. Yeah. What words did I use? Persistence of computation progress, or progress of computation. I don't know. I feel like I did use the word progress and computation and persistence, which is basically what's being said here. Progress is recorded durably so that computation can continue reliably. Ultimately, everything is also a log. Yeah. Whether it's a sequence of domain events, a durable workflow history, or a chain log back in a stream processor. The underlying idea is the same: encode system activity as a durable append-only record of what has happened and possibly what should happen next. Making durability, which by the way, again, another um, another example of where this is manifested is with time travel debuggers. I actually recently came across one that's specifically for Python, retrace. I mean, there are several ones out there. There is RR. There's undo. Those are the two ones that come to mind right away. I'm sure there are more. I think there is another company that does, but that one's more for the browser. Is it live replay or live session or something? I forgot the name. Browser replay or whatever. It's not entirely open source. You have to pay. It's like a website analysis or telemetry thing that you have to pay for. But anyway, the idea that everything is a log and you record, execution. So that you have a record of the activities. How did he put it? Progress is recorded durably. Yeah. Again, like, it will be fascinating to see a programming language where the runtime itself gives you this for free. Like, that actually will be sick, as if it gives you this for free and it gives you hard reloading also built in. I mean, we already have stuff like, live reloads. Like, you can patch the kernel if you're careful. There's such a thing as live kernel patch. Anyway, I'm just imagining a programming language that has durable execution built in, and also live reload built in. I mean, those two combined are such powerful ideas or frameworks to build on. I mean, debugging will be such a breeze, I think, like in theory, and it's compared to what we have today. Like, yeah. Anyway, let's come back to Earth. Everything is a log. Remember that, people. It's all logs. It's all state machines. It's all graphs. That's what Rick will say. Maybe. Who cares? I'm actually not up to date on Rick and Morty at all. Like, I have no idea which season is on. I don't even know what's the last season I watched. Anyway, making durability a first-class concern allows systems to be, again, just thinking about having a programming language with a runtime that has this as like natively part of the runtime will be amazing. Like there's so much code that's written out there that will just vanish. I think. Now, am I gonna build something like that? I mean, sure, if I could pause time and take 2, 3, 4, 5 years to do so, sure. Um, yeah, but yeah, I just think it will be crazy to have that just built into the language runtime. Recoverable after crashes, observable through replayable history, reliable across asynchronous boundaries, composable across execution models. Yeah. Um, yeah. This effectively is a start, but we need to break this down into more precise terms by creating a sample model for thinking about reliable execution and coordinated progress. Let's do this in part 2. Yes, we made it to the end. We made it to the end. Well, that was a really good introduction. Looking forward to um, the other 3 articles. Yeah, I mean durable execution. Everything is a log. Everything is a state machine. Everything is a graph. Choreography sounds great on paper. What you probably want is orchestration most of the time. The essence of durable execution is just the ability to record. Let's call them execution frames. Being able to record them, and this allows you the ability to have awareness of both local but also global states, and being able to recover from failures when they do occur. What else? Big ideas here. Yeah, I mean, reliable execution and coordinated progress. That's what's next. But yeah, overall, this was a really good introduction to the series, I think. As always, very high quality content from Jack. Thank you for putting your work out there like this. And yeah, so this was a comeback stream after being out for so many weeks. I hope the audio comes out better because I did some tweaks. So yeah, I hope that it comes out better than it used to be. If not, then I need to make more adjustments, or maybe just buy a different mic altogether. But yeah, the goal is for this week again. Maybe I'm setting myself up for failure, but the goal is to go through all 4 articles this week. So we did first one. Monday. The goal will be to do part 2 tomorrow, and possibly look at maybe go over this as well tomorrow. Although this is pretty long. I mean, if I'm able to start sooner than I did today, then maybe. But then again, I don't know how long the second I'm not sure how long this second article in the series is. I guess I can just find out right now. Oh, it's no short. I'll tell you that. It's not short. So, okay. Speaking of not making too many, not, what's the word? What's the saying? Not hatching, no, not something eggs before they hatch. Let's just say that tomorrow we'll do part 2, and let's just say that we're not gonna make any promises on going through this as well. All right. I guess this is it. Good night. Take care. If you've enjoyed this at all, please do like and subscribe. I'll see you around.